Now we're going to actually look at a wireless session. We're going to take apart a wireless traffic capture and see what makes it tick. Now, one thing I want to point out is, like wired traffic, wireless traffic is primarily concerned with the overhead involved in getting bits and bytes on the wire, well, in this case into the air on the radio signal. So the upper layer protocols such as TCP, IP, UDP, DNS, HTTP, and so forth aren't really a consideration for the lower level devices. As far as they're concerned, all that traffic is the same. Its job is just to get it out in the air. So most of the protocols and stuff we'll look at with wireless traffic is mostly the lower two layers of the OSI model, the data link layer and the physical layer. And just like wired networks, wireless networks are concerned with getting frames transformed into ones and zeros and sent out. So that's why we're going to really look at the layer 1 and layer 2 protocols and standards. Now, most wireless traffic, as I mentioned before, is kind of overhead traffic, and we're talking things like beaconing traffic, key exchange, and so forth. All that overhead supports the transport of upper layer protocol traffic and converting it to a usable format to send as radio waves, just like a wired network would convert it to ones and zeros and send it over the wire. So that's really what we're looking at with a wireless session. So with that, let's actually go ahead and look at a wireless traffic capture, and I'll try to point out some of the things that you need to look at when looking at wireless traffic. Okay, we're in Wireshark, and as you can see, we've got our standard packet number, time index, and so forth. Source and destination, basically, you're going to see a lot in the source column, and this basically is our wireless access point's MAC address. And like a lot of wireless access points out there, this is a Cisco Linksys I'm looking at. You know, the first half of the MAC address is the manufacturer's code. So we've got this MAC address, and then the destination, and a lot of this is going to be broadcast. A wireless access point basically is a radio transmitter and receiver, and it broadcasts out a lot. It lets wireless hosts know that it's there. Now, these wireless hosts can connect to the wireless network if they have a few pieces of information. First of all, they need the SID, the SSID, or wireless network name. They also need any encryption information that would have to match up with what the wireless access point is programmed for. Now, most radio frequency finders, Wi-Fi finders, laptops, and so forth can pick up wireless signals even if they can't connect to the network. So you may actually pick up the signal because all this broadcasting is going on, but the SSID may not be broadcast, and even if it is, it may not be possible to connect to the network because of encryption. So you're going to see a lot of broadcasts, and for the most part, most wireless devices can pick them up. Now, you're also going to see in the protocol type the different protocols that we have. And of course, there's really only one protocol that we're concerned with wireless, and that's 802.11. And as you know, there are several different standards. There's the A standard, the B standard, the G standard, and now the latest standard still in draft is the N standard. And all these progress from basically to faster data rates and better strength transmissions. Now, if we look over here to the info section, we've got what kind of frame this is. It's a beacon frame, meaning it's a broadcast out. It's sending out saying, I'm here, I'm a wireless access point, and here I am. So we've got certain flags set, certain information such as serial number. We've also got the SSID located here. And if we actually go down a little bit, we can take apart some of this information on this frame. Let's look at our middle pane here. We've got frame 1, and it gives us some information such as timestamp, frame number, frame length, and so forth. And it tells us what kind of encapsulated protocol is in this frame. It's a wireless LAN. It's not an Ethernet protocol. It's a wireless LAN protocol frame. So then we've got the beacon frame, and we can look down here, and basically, again, this is a frame that goes out over the wire, or in this case over the air, that tells computers, other hosts, that it's there. It's a broadcast frame, so you can see that it goes to the broadcast address, all F's, which, you know, is as an IP address is 255.255.255 and so forth. But we've got our source address here, our source MAC address, our basic service set ID, fragment number, and sequence number. Now we've got another part to this, and this is another layer 2 protocol, our 802.11 wireless LAN management frame. We've got some parameters here we can look at it, and again, timestamps, intervals, that's how often the beacon is sent out. Some other information down here, capability information on the frame itself, and then we've got some tag parameters. Tag parameters talk about what parameters are being broadcast out with that beacon, such as the SSID, which is VTC-test, our supported data rates, so that hosts connecting will know at what rate this access point can transmit and receive, the current channel it's on, some other information that may or not be relevant to your packet analysis, but ERP information, vendor-specific information, such as what kind of network card is in the device, and other capability information. Right here we see that this is an 802.11n capable device. So we've got lots of different information in these beacon frames. Now some of the other information we send out, we can get replies back, of course, probe requests and probe responses, and these are usually from hosts. So other hosts can send their probe requests and probe responses out over the network, and we can get different information from them as well. But all this is broadcast based, except for the occasional probe response. That's almost like an ARP request and an ARP response. One is broadcast and one is directed. And then we've got some other information down here that we can look at. We've got, we go down here to frame 168, I think it is. This is actually some encrypted data. And this is where the WEP exchange began. And we started exchanging WEP keys and so forth, so we could encrypt traffic. So we don't have a lot here that we can show you, and what we do have, of course, is encrypted. And we're going to talk about WEP a little bit more in a session very soon after this one, so we'll take WEP apart a little bit more. That's essentially the breakdown of a simple capture, simple wireless capture done in Wireshark, and what we've done is point out just a few of the basic components of a wireless broadcast. And what you need to remember is the wireless is basically at the first two layers of the OSI model, layer 2 and layer 1. So that's where you're going to see a lot of your wired, or rather wireless relevant traffic. Upper layer protocol stuff you'll see in a normal capture anyway. So that's basically a elementary wireless capture.